That's not what I wanted. How do I computer? Wallboard, split screen. Split screen. All right, cool. You guys are as interested in Ruby as I would expect. It's what? Oh. Wait, is everyone? Hey, everyone. No, I'm just having a private conversation with Mish. You guys keep talking. No. So who's enjoying Ruby today? That's like the same amount of hands when I ask who's enjoying CSS today. Yeah. So Ruby's as good as CSS. Good to know. Okay, let's talk about some stuff and things. How's my screen? Is it orange enough? Yeah? Okay. Did anyone watch the WAP video yet? Let's talk about Ruby. No one watched it? I feel... I'll show you the Ruby part of... No, because the audio won't be loud enough either. Alright, I know, right? Thinking the same thing. Hey, guys in the back. How do I create an object in Ruby? Not everything. Every expression evaluates to an object. That's everything is not an object in Ruby. Jeremy, what is not an object in Ruby?
Ifs are not objects in Ruby.
Ifs are not objects in Ruby. But an if statement will evaluate, if I do it correctly. How do you... Do I have to do a semicolon? Yes, I do. An if statement will evaluate to an object. Nil. Nil is an object. But if by itself is not an object. Like, you know, I can't... Wait, can I? If...
A block object?
Yeah, they are.
I don't think they are. I think you can turn them into objects.
So, good enough. So close enough. Yeah. Not everything is an object. An if is not an object. How do I create a new object? There is no. Everything's an object. Nothing's an object. Damn it. Yeah. How do I create a new object, guys? If I want a new object, how do I create that? I could go like object equals object.new, right? Does that create a new object? What? Oh, what? Oh, not net, new. Sorry. Yeah, so what is obj? That represents an object. Right, it's an instance of object. What is object? Capital O object. It's a class. It is a class. I don't even know how to prove that it's a class. Is there a type of in Ruby? Whatever. Object is a class, so I can create a new object. In JavaScript, when we created a new instance of a class, we did something like this. In Ruby, it's a method. A lot of things are methods. Like a lot of things that you wouldn't expect to be methods are methods in Ruby. Has anyone noticed that? Right, like if I wanted to add 1 to 1, that plus is a method. Yeah, like it's a method that accepts a parameter. So that's actually what's going on. It's weird, right? Yeah, so Ruby has syntactic sugar. That lets us type it like this. But a lot of things are methods. A lot of actions are methods. So if I want to create a new object, I create a new instance of a class. Object is a class in this case. Every object is an instance of a class. We can't just create an object on the fly like we could in JavaScript. Every object is an instance of a class. If I have an object and I want to add a method to it, how do I do that? So I create object, I don't know, what would be a good method for my obj? Actually, what's a good method? Yeah, sure, why not? Let's do obj.myth. What does myth do? Puts jazz hands, obviously. And alright, cool. Now I can say obj.myth. Yay! Object-oriented programming. That's how I add a method to an object on the fly. What methods can I call on object? Like, how many methods does it have? I can call, obviously, myth, because I define that. What's that? Well, let's just, like, as many as you want. What happens if I type this? Because I didn't spell you right, isn't it? No method, error. Undefined method, as many as you want. So which methods are available for me to call on object by default? I just create a brand new object, object.new. What can I call on it? So there's what, 2s? Yeah, I can call 2s. What does 2i do? Where are these methods coming from? There's a lookup process similar to JavaScript. How can I see all of the different methods I might have access to? Almost. Just call .methods on the object and you can see all the methods you have. So we could do, oh look, instance of, question mark. What do method names with a question mark at the end mean? Yeah, hopefully we'll get back a boolean. So let's see if object is an instance of object. Yay! Let's see if object is an instance of basic object. False. Cool. Yeah, it's an instance of object. Obviously, we created it saying object.new. So, here are the methods that come as part of, or here are the methods that exist on object, or most of them do anyway. So when I create a new instance of object, I can call these methods by default, and I can define my own methods to call on the object. Any questions so far? No? Cool. All right. I realize now I should have eaten this coconut first, because trying to eat a coconut and do a lecture is probably not the easiest thing to do. I got the coconut water, so I get some more. Punctuate my sentences with coconuts. All right. Okay. Cool. So I have an object, and I can call method. Is it method? Method. There we go. This is not a very efficient way of doing object-oriented programming. Creating objects on the fly, let's say object2 equals object.new, and then just defining methods to be shared with them, or whatever. We, in Ruby, have a way of organizing our code, and that way is called classes. A lot of languages have classes. Some languages use them more than others. A language like Ruby, classes are meant to be the solution to organizing your code. So every problem you have in Ruby should be solved with classes. In Ruby. Remember what I said about JavaScript? There's no correct way of doing object-oriented programming. Yeah. In Ruby, there is, and it's called classes, and just do it with classes. Okay. So let's create a class. Yeah. Oh, yeah, right. By the way, this thing is called duck punching, just adding a method to an object on the fly. If you're like, oh, this object doesn't do this thing I want to do, so you punch it until it does. You're like, object2 doesn't have like a jazz hands method. Ah, damn it. Okay, let's just like punch it in there. Def obj2 jazz. Whatever. You get where I'm going with this. So let's create a new class. What are we making? Do we want to do sharks again or something else? Yeah, what should we do? I was, but that's gonna make me hungry. Burritos. All right, you got burritos to beat. Anyone? Coconuts? There's no emoji for coconuts. Oh wait, I think there might be now. There used to be the palm tree. Oh, there was. Yeah.
Things to buy at TNT.
Things to buy at TNT.
That's still food. And edible.
Planets? I don't know, sure, let's do planets. That sounds like it could be fun. We're gonna do a space themed thing. No.
No.
Astronomy is fine, astrology is not. All right, okay, yeah, so we need planets. So in Ruby, I need to represent a planet somehow. How do I do that? Create a class. What should I call the class? Planet, singular, because each instance of this class will represent a single planet. The convention in most object-oriented languages, including Ruby, is to create a new file for each class. Anyone guess what I'm going to name the file? Planet. Singular again, not js.rb. So I have a planet.rb file that will contain a single class planet. That's it. Nothing else. No more logic. Nothing to do with anything else other than the planet itself. Damn it. If I could just do lectures with like hand gestures and no laptop, would I be doing lectures better or worse? All right. So I've got a class planet. Obviously, I have to end the class. What do we want our planet to have? Whoa, this is like a generic template for any planet I might create.
Gas, mass, and aliens. No one rides for free.
All right. How do I?
If this demo doesn't end with gas, mass, and aliens, I'm going to be really disappointed.
No, it's a gas mass and aliens. No, because I sit here with nothing until I ask you, and then I get gas mass and aliens. This is what object-oriented programming is all about. This is what Ruby intended. Okay, so let's set up some default state when we create the planet. So every time we initialize a planet, we're going to give it some gas mass and aliens. Sound good? Yeah? Okay. All right. So there is a special method that you can add that gets called. There we go. Special method that gets called on every class when you instantiate a new instance of that class. That method is initialize. Yeah, exactly. It's kind of like which method in JavaScript? Kind of like constructor. Initialize. So we're going to initialize it with what? Gas, mass, and aliens. What's the type of each of those going to be? I don't know. All right. So what should we do? Should we just like let's store these on the planet itself? How do I store the values of each of these variables in the instance of planet? Instance variable. How do I create an instance variable? @ followed by what? Yeah, look at you guys. Gas equals gas, mass equals mass, and aliens equals aliens. Aliens. All right. I guess we could have like default, like aliens can default to 0? Sure, I don't care, whatever. Oh, you think aliens should be true or false, not number? Okay, cool. What do you mean count up with aliens?
So we know how many aliens there are.
Okay, that is the only incorrect statement I've heard. We will never create a class variable, ever. But apart from that, I like all your suggestions. So what should aliens be? Not a boolean, like an integer then?
Wait, what if we need to be able to report how many planets have aliens?
Calculate it on the fly, I guess.
Out of what?
I don't know. I guess you just have to figure it out a different way.
A class variable. This is at least broadly a good suggestion. Maybe not a day one breakdown suggestion.
I don't know. I kind of want to like give you the finger and say, let's just create a global variable.
Yeah, me too. I also want to give you the finger and say, let's just create a global variable.
Yes.
Sorry.
What's up?
He's been trying for like 5 days now to get me to this lecture, but every time I'm like, I'm happy to trash talk Ruby in front of all the students.
No, it's good because if you're talking, I can take a bite of coconut and it doesn't create an awkward silence. See, now it's an awkward silence. Hmm?
But it's not awkward until somebody points out.
Yeah, and that was Sam's last lecture ever. I should stop way before that. Before we get to genitals. That should be the line. Alright, what do you guys want to talk about? No, I kind of like aliens. Aliens can imply life because, you know, we could do like the Ruby thing and have multiple names for the exact same thing. So it could be aliens or life or something else that rhymes. What should aliens default to though? An integer or a boolean? Really? Not an integer? Okay, whatever. So false, but also like maybe life will also be aliens just to confuse people. Yeah. All right. Let's create a new planet. How do I create? Oh wait. So just my class should go in here. So let's create a new file. I don't know. What should we call it? What's like the entry point to a planet's application or a astronomy? What are we building? Yeah. Solar system.rb. Sure, why not? In solar system, I'm going to require planet.rb. Wait, how do I require? Is this right? That looks about right. What about like require relative?
I don't know. It's just require on our thing.
What about include?
I don't know if that works.
Yeah, all possible things I could do. Let's try require. And let's create a new planet. Which planet should we create?
Yeah, are we making a solar system?
Yeah.
Yeah, let's make planet Ruby.
I'm sorry, what you said, Ruby? Let's call it like a gem. Gem planet. Planet new. What does planet need? It needs gas, mass, and aliens. So what do we pass in for gas and mass? Gas. What should we pass in for mass? Heavy. Wait, is it a string or a number? Let's make it a number, and it's just an arbitrary number. What? Yeah, it could, right? Planet's mass could change. What if an asteroid hits it? Right? Yeah. Right? Okay. Cool. I'm not sure. Let's see if this works. Yeah. Okay. What am I doing? What do we call it? Planet, solar system, Ruby, solar system. .rb. Command not found, Ruby T. Oh, right, okay, yeah, that's... should really fix that. Cool, we got a planet. We got a planet. Does that help in any way? PP is undefined. Good job, Sam. There we go. All right. Use P so it calls inspect so we can see the instance variables. All of these are variables on the instance gem. Cool, that looks like a pretty good gem. That's what it's got for gas, mass, and aliens. And life, obviously life. Cool. Alright. So now I want to do something with that stuff. Yeah. Initialized it with some data. We've stored that data on the instance. Can I now then, let's say I wanted to, HLP gem, and then underneath I want to put like gem.gas. Why can't I do it? Because I don't have a undefined method gas for instance of planet. Every time you see the hashtag, it usually means instance of a class, instance methods, instance of whatever. So we have an undefined method gas. It's trying to look up a method gas, but I want it to look up the instance variable gas. So how do I do that? The what? Something like self or something. You're saying words that are relevant to classes, yes. Not to this though. So there's the attribute accessor things. What do they do? So these instance variables right here are not accessible to anything other than the current class. It's not super helpful. I want to be able to access gas. Every time we use this dot notation, we are accessing a method. So I'm accessing the method gas on gem. Methods can expose data and allow us to set data, but we can't actually expose this instance variable. We can only use methods to do that. So I can define a method called gas that just returns gas, and then I'll fix that problem, right? I can now access the gas method, which returns the value of the instance variable gas. So, gas. Do the same with mass. Mass, mass, and aliens. Okay, now I should be able to access everything, right? Gas, mass, aliens. Can I just add adder accessors instead of doing all of that? Can I? Absolutely. What does that do though? What is, okay, so we're talking about adder accessor. So after.
You can make your decision on if you want it to be readable or like if you can read it, if you have useful or.
So what is it, reader? Yeah. Is that right? I think.
Yeah,
Okay, so
reader and then there's accessor.
what is adder reader? What is this thing?
You can only read it, you can't change it.
But what is this? Is this a variable, a method, a class? What is adder reader? Symbols look like that.
It's a method that
It is a method.
symbols.
It's a method that takes symbols. Okay, so we could call it like this. It's a method that needs the names of the instance variables that it's going to expose. So, you know, gas, mass, mass, what's the other one? Aliens. It's like, what are the names? Just pass me the names of the instance variables and I'll write the methods to expose them. But since these are all constant strings that are never going to change, we are going to use symbols. And then we take away the parentheses because that's just the naming convention for add a reader. This is the equivalent of this. I usually put these at the top of the file as well. So instead of having to define all these long methods, I can just say this, and it should be the exact same thing. Cool, that's pretty nice. Sweet. How do I... Actually, this is kind of a good time to talk about why we're using classes, or one benefit of using classes. Have I told the car analogy to anyone here? Like, might have been in week 5, or I sometimes use it in week 1. The difference between an interface and an implementation. Okay. So, let's talk a little bit about why all of these things would be completely private by default and not public. Why wouldn't they just be accessible by default? So, I want you to think about a car for a moment. Does everyone here know how to drive a car? Yeah? Okay, so this isn't lost on anyone. Think about a car for a moment. Think about how a car is built. What consists of all the pieces of a car? That was a weird way of wording that. What is a car made up of? Right? Yeah, love wheels. Steering wheel, engine, yeah. Who knows how an internal combustion engine works? We got 1, we got 2, right? Like everything about it? Okay. You know enough about how, who knows how a clutch works? Yeah, a couple of people. Drive shaft. Yeah, things like that. Got a couple of people that do know all about it. Does it help you drive the car?
Well, actually a little bit for
Yeah, maybe. All right, maybe a little bit stinker. Who knows anything about electric motors? Oh, cool. Huh? Same people. Yeah. Is it just a car thing, or you just like motors? And you took apart electrical motors too? Ah, okay. Two different things. Yeah, still. Do you need to know anything about either of those, any of that, to drive a car? If a driver, anyone that doesn't know anything about engines, starts driving a normal automatic car and then switches to an electric car, do you need to change what you already know? Do you need to change your knowledge, or can you go ahead and just drive that car immediately? Yeah, right? Exactly. You know it, right? That's it, though. You know where the go, the stop, and the thing that makes it go left and right. And that's it. And maybe, like, this can make it going backwards and forwards. Everyone with me so far? Cool. Where's he going with this? So the pedals, the steering wheel, what is this thing called? Yeah, but like in an automatic car, is it still a shift? Sometimes they're up here, sometimes they're like that. Yeah, sure, the gear shift. The pedals, the steering wheel, the gear shift. That is the interface to the car. That is what most people are exposed to. That's all you need to know about in order to drive the car. Maybe I guess where like the gas thing is. Yeah, we're gonna forget about standard. I was like, yeah, if you were on those first cars, you need to know how to use that thing where you like wound it to begin. Yeah. Too many ifs. Yeah, that is the interface. Okay. That is all that is exposed to you because that's all that needs to be exposed for you in order for you to drive the car. You don't need to be exposed to the internal workings of the engine or anything else. You just need the simple interface that allows you to get around. On the other hand, what actually makes the car able to go around is the implementation of the car. All the things under the hood, every piece of the car that you don't have to think about while using it is what makes the car a car and what makes you able to drive the car. One thing is the implementation, one is the interface. And we talk a lot when we're talking about object-oriented programming and programming in general actually about the benefits of encapsulation and what's the other word that's buzzword that's used a lot? Encapsulation and Abstraction, there it is. Encapsulation is encapsulating every complexity within a class and only exposing what you need to. And just creating these abstract data models that are pretty simple to program with. Now, when we're doing it with classes, we're creating these interfaces for other programmers to use. So, by default, if myself or another programmer comes to this class planet and wants to use it, let's say from another file like this, the interface suggests that I can create a new planet with gas, mass, and aliens that is exposed publicly. If we didn't do this at a reader, then nothing else is exposed publicly, and it's a very simple interface for me to use. I can create a new planet and do nothing with it. It's not super useful, but it's a very simple interface. If everything was public by default, then any developer would be able to come in and get messy with the implementation details, and that's not what we want. We want simple interfaces and keep all the complexities away from developers, including ourselves. So, in Ruby, everything by default within the class, rather instance variables by default, are private. They're not exposed, because they shouldn't be exposed. You should only expose what you need to expose. Okay, so with that in mind, right now we can initialize a planet and we can read its properties. Should we be able to do something like change its properties? Should anyone that creates a new planet be able to just on the fly change a property like this? Do you think? Well, this is adding mutability and maybe unnecessarily. So if I create this new planet with this type of gas, this mass, and aliens, whatever, and then pass this around to other functions, and then just go ahead and mutate it, it might affect other parts of the application unnecessarily. Maybe we shouldn't give developers using this class the ability to do that. Be like allowing a person to just be able to, like, I don't know, how would that work in a car? Remove the engine or not easily. It's like, yeah, sure, I'll just remove the engine. That'll make me go faster, right? Less weight. And then you realize you can't drive the car anymore. I probably shouldn't have just, like, left the engine on the side of the road back there. Analogy work? Maybe. No? Okay.
When you're in driver training, someone has a brake on the other side. You keep braking for me.
Yeah. Okay. Maybe. I don't know. It fell apart there. Let's pretend I didn't say that. We don't want to allow people to do too much. We don't want to give away too much mutability. So before you start exposing things from classes, before you start making anything public, anything accessible, you should really think about what actually needs to be accessible, what needs to be mutable, and how should it be able to be mutated. So sure, we could maybe just change the gas of a planet like this, but maybe that's not what we want. Maybe we want to allow other parts of the code to alter this, but maybe we don't want it to be completely changeable to anything. Maybe we don't want people to be able to set gas to jazz hands. Maybe we want to set certain restrictions on that. So this is where we can create interfaces to actually restrict certain things. So first of all, let's test this out. Will this work? Can I set gas? Yeah, I only have it as a reader. How do I actually make this doable? How do I do it without the adders? That's a funny looking method. Is that right? That's a weird looking method, are you sure? Okay, so then I'd have to come in here and I'd have to say like this, right? Pull it like this. And then let's pgem. Yeah, all right, look, we set the gas to this. Yeah, Ruby syntactic sugar, right? When we have the equal sign among other things, we're allowed to do this kind of thing. So we can override or define a method that is gas equals, which will allow us to set gas just to whatever we want. Cool. we could do that for every method in here, like this, or we can create accessor, which would make it readable and writable. Okay, everyone seems like they already knew that, so that's good. I don't want to do this though. I don't just want to make this writable. That just seems wrong. You shouldn't be able to just set gas to whatever you want willy-nilly. But that would do that. Instead, how should we restrict what people can set gas to? Like, maybe it can change, maybe it can get worse or better, but it can't just completely change. What do you think? Yeah. All right, so let's define a method, which is defining something in our interface. Let's say, like make gas worse or gas got worse? I don't know. This is weird examples. What happens if you make gas worse on a planet? Should we choose a different example? Should we do gas, aliens, or mass for this one? Okay, so let's do aliens. So what should we do? Like, we don't want to just be able to. No, because it's a Boolean. I was gonna say we could like increase the number. What's up? Oh, we could do life. All right, life is what then? What? What is life? Yeah. Okay. So life is 0. Sure. Let's do increase. Sure. Life plus equals 1. End. Okay, so I don't want you to just be, I don't want users of this, for whatever reason, to be able to set life to whatever they want. They can increase and decrease and that's it. It starts at 0 and you can only increase or decrease. You can read it. Let's make this a readable property. But I don't want it to be settable. I want to kind of restrict how this might be set. Maybe I will make gas settable. It seems like something that would be fun to make settable. Okay, so we can increase life and I guess decrease life. Decrease life. Seems good enough, right? Minus. Yeah, how's everyone feel about that? So then let's gem dot increase life. Yeah, look at that, life's 1, so we increased it by 1. How much life should we give this planet? You got 8. Do I hear 9? Anything higher than 8? Any random number? Really large number. Okay, 40,000. You know you can write numbers like that. It's kind of nice. 40,000 times do end. Look at that, 40,000. Yay! You said that was pretty fast? Yeah, we should benchmark that. Who knows how to benchmark though? Yeah, one person laughed. That was a little bit slower. 4 million lives on the gem planet. Cool. Any questions? I didn't want to do that. No? Everyone good? All right. Let's talk about inheritance, because that's something that's going to come up. We have a planet. Let's do some inheritance stuff. You already kind of get the gist of it. So should we create like a subclass or a superclass to planet? All right, what would be a good subclass of planet? What? What did you say? Did you say stinky? Steamy. Oh, steamy. Ooh, a moon is a planet? Is a moon a planet? Yeah, exactly. Or we go the other way, and no, I think yeah. So what would be what would all the things that a planet apply? guess a planet with a moon would also have moons. Maybe something a little bit more fun. I don't think that's a planet if it goes supernova. And it wasn't a planet to begin with, it could go supernova. Huh? Earth-like planets? Shark planet. Shark planet! Boom, done. Alright, if I'm creating a new class, do I put it in this file? But it's a planet. Don't I just do class shark, put all the planets in here? You create a new file. Called what? Shark Planet. Shark Planet. Where they play Jaws all the time. Yeah. Alright, class, Shark Planet. Cool. So let's require, wait, into my solar system. Let's require some Shark Planet. Whoops. Oops. How do you require a thing that's, is it just Shark Planet? Do I have to case these? Right, even though it's... Yeah, right? Require could not load file, yeah, so do I just do like Shark Planet? Yeah, it looks like it works. Cool, alright, that's fine. I'm not actually sure the convention there, so if you see it written a different way, probably do it that way. Shark Planet. Okay, so now I can create a new Shark Planet. Yeah, let's create a new... Let's comment this out for now. Let's create a new Shark Planet. What should we call our Shark Planet? Shark Planet. Whoops. Shark Planet. .new. Okay, so I can... Let's see, I guess I gotta call it with these things. What's the gas on a shark planet? I don't have blood as an emoji. Man vampire. And how many mass? Cool. Okay, so we got Jaws with that and that. Will this work? Creating a new shark planet like this? See what happens. Yep. Wrong number of arguments given to expected 0 on the initialize method on... Oh, it doesn't say. It doesn't say shark planet anywhere. That's so rude. Anyway. I ran it in solar system. Anyway. Expected 0 given to... Yeah, obviously, because we just have a shark planet. It doesn't have an initialize. Doesn't have... Yeah. So yeah, how do I do this? Do I define a new initializer? How do I say this is a planet? How do I write extends in Ruby? Yeah, you spell extends this way in Ruby. Planet. And then I also need to require the planet, so this file knows about it. Require planet. Okay, now will this work? Now that Shark Planet inherits from Planet, can I just, without doing anything else, without writing any more code, like just these lines, can I start using these methods? So the first one, can I just like use this initializer? Will I be able to pass in gas and mass? And will aliens be false and life be 0? Alright, let's find out. Guess I should save that. Solar system. That looks good. I forgot what? Thank you. Shark Planet has R. That's the Unicode. It couldn't figure out what a vampire was. Ooh! I want to try something. Is there a shark emoji? Yes! I'm so sorry, but we're going to try this, and if it works, we're going to have to do it. Do you think? because it's UDF-8 encoding that this I could actually call my class, which means that Shark Planet. Damn it. Why? Because something. Oh, I guess it's because maybe a shark isn't a capital letter? Maybe. I mean, like, anyway. Couldn't figure out. Anyway. Probably can't. Anyway. How do you have a capital shark? So, that worked. Sweet. But we want every Shark Planet, when it's created, to have these properties by default. I don't want to have to pass these in every single time we create a Shark Planet. So how do I make sure that these values are the default values every time we create a Shark Planet? Like, I don't want to pass that in, I just want it to be that by default. So how do I set up some default values when a class is initialized? Initialize. My planet is expecting 2 parameters, maybe 3. Right, but do I need to specify gas and everything in here? Does this need to expect the same amount of arguments that the superclass does? Or can I go completely custom here? Yeah. Super. What does super do? We want vampire and 7. Let's think about this. What we actually want to do. We want to set gas to vampire. Making sure I got that right. Seems weird that we would set gas to vampire. We want mass to be 7. And then we want all the default behavior from planet, which would be basically this. Right? I want to do all of that things. I want to set these up as custom values, but then I want these to be the same as the superclass. So by calling super, I'm saying call this method initialize on the superclass. So this is going to call the initialize of the superclass, which expects 2 parameters. One of them's default, so we can leave that off. And it will actually do all of that setup for us. It would set gas, it would set mass, aliens, and life. Right? So if I just call super, it's the equivalent of calling the initialize on the superclass, where I can just pass in those default values. So I could say super, exactly what I got at the top there. And then I don't need to do any more of that stuff. Does that make sense? Any questions? So now the initialize for Shark Planet doesn't take any parameters, so I don't need to pass anything in. And when it gets called, it calls the initializer on planet, which then sets up all these variables. So if I rerun this code, it should be exactly the same as before, where Shark Planet has vampires and other things. Let's see, yeah, that looks like a vampire. And mass 7, aliens false, life 0. Cool. Any questions? Concerns? Comments? No? All right. Let's see, what else should we cover right now? Inheritance, class methods, override methods, initialize, super. Yeah, I think that's mostly everything. How much time do we have? A couple minutes? Okay. So one other thing I will show you is class methods, because they do come up. A class method is a method that exists on the class itself. So new looks like a class method because I call it on the class. Whereas, let's see, jaws.increaseLife is an instance method because I call it on the instance. Class method, instance method. Okay? If, let's see, I think, yeah, we're going to do it this way. in my solar system file, I actually want to create a default solar system class. But there's only going to be one solar system per application, like it is a solar system application, so we're just going to have one solar system, so I don't really want to be creating new instances of this class. I just want to have a class because classes are a nice way of organizing my code. So instead of initializing a new instance of that, I just want a method that kind of just says like start my application, right? My goal is that I want to call solarsystem.start, and it just kind of does my initial code. It starts my application for me. Okay? If I write my class out this way, will it work? And here's like all my start code, like making sharks and stuff. Why wouldn't that work? Yeah, right? Like, in order for this method to work, I would have to say a new instance of solar system. But sometimes you don't want new instances of a class. You just want to be able to call it on the class itself, right? So in Ruby, we do this with this syntax. Self being the class that I've defined this in. So now, it's the equivalent of doing this. So now I have a method start that exists on solar system, which means that I'm actually going to put this so we can see something. That if I start my application, we'll just get this bit of code coming out. Boom, start code, like making sharks and stuff. These are class methods. They have some use cases where they're a good thing to use. Most of the time, they're a bad thing to use. Most of the time. The reason I want to bring this up now is because you will see this used in Rails a lot, and probably even tomorrow in your active record stuff. You will see class methods used. And I just want to point out that there is a difference between a method you call in a class and a method you call in an instance of a class. So I'm not creating a new instance here. I'm not going to create many solar systems and tell them all to start. It's just one class method. It's basically a method that exists on this namespace. Okay? And then I could, like, you know, create my jaws and stuff in there. Boom. All right. Yeah. If I create an instance of solar systems, I can do that like this. Can I call start on it? Undefined method start. Yes. So remember that the class is actually an object. Solar system is an object, and that object has the method start. Start. An instance of solar system is a different object which does not have the method start. No, in JavaScript we also have class methods. They just look like this. So if we have class solar system, I think you just say class, something like that, versus an instance method which would look like that in JavaScript. No, because the prototype isn't the class. The prototype is the class.prototype. Which brings me back to week 6, day 5, and the confusion of prototypes. And that method. Yeah, you know, it's like how in JavaScript, just to confuse everyone that thought they were over that, the constructor function is not the prototype of an instance of that. Let me see, yeah. So the function itself is not the prototype of whatever I create from the function, it's the function's dot prototype. So it would be that thing. So you could actually have a method that exists on the function that wouldn't ever make it in the prototype chain because it's the function's prototype that becomes. I guess if that helps you make sense of this, yeah, this is not like it's superclass. It's nowhere in the class hierarchy in the prototype chain, whatever. This is a different object. This class is a different thing than any instance of the class, and different than any superclass that you would also create an instance of. Okay, pretty much at time there. Does anyone have any questions, any final things that you'd like to go over? Are you using VS Code? Okay, so you can hold the Option key and click in as many places you want. You get cursors. You can also select one place, like right here, and Option, Command, and up and down arrow, and you'll get that. You can also use Option and the arrow keys to go one thing in each direction, like maybe it's a word, maybe it's a character, whatever. You can use Command arrow keys to go to the end of front of the line. But I could do that to like rename all the things. I don't know, you get used to the keyboard shortcuts after a while, it makes it fast. Like, let's make these all global. Yay. Let's not do that. No idea. Messed up?
No math type.
Oh, mass type. Whoops. Sweet. No other experiments you want to try? No? Some of you looking like you want to go to sleep? So the @ sign, yeah, one thing I should verify. Within a class, the @ sign represents an instance variable. So in this case, gas is a variable that only exists on an instance of Shark Planet. If I created a symbol, that would literally just be a symbol. If I created a local variable, it would be a variable that only exists within this method. But by doing an @ sign, this only exists on an instance of Shark Planet. Double @ sign, again, try not to use these, but you'll see them in Rails and other places, means an instance, no, a class variable, a variable that exists on Shark Planet, the class, versus an instance variable that exists on an instance of Shark Planet. I mean, this just is not good programming to be able to actually store data on, a little water, on the thing itself. Yeah, in this case, all we won was we didn't have to do default arguments. We could also have custom behavior or override behavior. So on Shark Planet, when you increase life, I don't know, how many babies do sharks have at a time? Let's just say 10. I think that's incorrect. When you increase life on a Shark Planet, you actually increase by 10. And when you decrease life on a Shark Planet, I don't know, you set life back to 0 or something? I don't know, something weird.
And that only
Yeah, so if you have an instance of a normal planet, life increases and decreases normally. If you have a Shark Planet, it's crazy. And then you can have custom behavior, you know, like the planet itself can go for a swim, because why not? Because Ruby. And I don't know what that would do. As well? Yeah, anyway. So you would override existing behavior and you would implement custom behavior. That's usually why you would subclass. And add new state. Subclassing is not, I mean, it can be handy at times. It's not like the thing you have to do or the thing you have to take away. If you're just creating classes without subclassing, awesome. If you find a good reason to subclass, like maybe this was, maybe it wasn't, then you can start overriding state, overriding behavior, and adding new behavior and new state. I think that's everything. Any other questions? No? Cool. All right. Have fun with two-player map.
I was curious that before when we made subclasses, it was because we wanted to make like a killer rabbit, so we would replace one of the.
So
Like you would want to change the state. That's what I remember doing.
yeah, you could create a killer rabbit that like you want it to have all the behavior of rabbit,
But also have a laser. Like
but also
that.
have a laser.